Okay, so for homework, you should have already determined that the possible rational roots would be plus or minus 1, plus or minus half, plus or minus 2, or plus or minus 4. Now let's use them. So which possibilities are actual roots? So remember our remainder theorem. If we plug a value in to our function and get an output of 0, two things. X equals a is a root. X minus a is a factor. So, like I mentioned in the previous video, you started this chapter by being given a root. Now it's up to you to find them. Okay, so into our original, we're going to replace all our x's with positive 1. 2 minus 9 plus 3 plus 4. Negative 7 plus 7 is 0. So first try, always start with positive 1. It's the easiest number to evaluate. First try, we get x equals 1 is a root. And I'm just going to go through the steps. If you started with negative 1, okay, so remember negative number to an odd power changes the sign. Negative 2 minus 9 minus 3 plus 4. So this clearly does not equal 0. Okay, so once we find a root, we use synthetic division until all roots are found until a polynomial can be factored. So 1 is my root, coefficients, x cubed, x squared, x, constant term, bring down, multiply, add, multiply, add, multiply, add. So we do in fact verify what we already know, a remainder of 0. I started with x cubed, so my quotient is a quadratic. So now let's factor this. So there are factors of negative 4 that add to negative 7. So negative 8 plus 1 would give me negative 7. So my two other roots would be negative half, positive 4, in addition to the positive 1 that we found. Okay, so that's how we use it. You have to find 1, and then from that 1, we just continue until we've factored and or found all the roots. Okay, so another example, you verify that these are the possible rational roots for this polynomial. So I'm going to start at 1. So f of 1, 3 plus 2 minus 9 minus 12 minus 4. So 5, if I subtract all these numbers, definitely not going to equal 0. So let me move to negative 1. 3 minus 2 minus 9 plus 12 minus 4. 1 minus 9 is negative 8, plus 12 is 4, minus 4 is 0. Perfect. So I'm going to put negative 1 in synthetic. 3 x to the 4th, x cubed, x squared, linear term, constant term. Bring down the 3, multiply, add, multiply, add, multiply, add, multiply, add. Perfect. So we already get a remainder of 0. So now let's think about this. We started with an x to the 4th. This right here, our quotient, is a cubic polynomial. Now, if you were to stop here, you would have to be able to factor that as it is. You cannot factor by grouping, or you have to go back through finding all the possible rational roots. So back again, 1, 2, and 4, positive 1, plus or minus 1, plus or minus 3, and you got to go back through the whole rigmarole of plugging in and finding which one gives us 0. So before you jump there, always check. So from this step, we're going to check, is x equals negative 1 a double root? Because if it's a double root, I'm going to go through synthetic again, and if I get a remainder of 0, it puts me in a good spot for solving. So let's check a double root. Just remember, we then took the coefficients of our quotient. So 3, negative 1, negative 8, negative 4. Bring down, multiply, add, multiply, add, multiply, add. So is x equal negative 1 a double root? Yes, it is. And and a lot of things are good for us. So right now I know that x plus 1 quantity squared, that's a factor of my original. And furthermore, look at what our quotient now is. It's a quadratic. And now from here, we can attempt to factor it or use the quadratic formula. So I'm going to go to the next slide here. Okay, so I already know x plus 1 quantity squared is part of the factored form. Verifying a double root gave us 3x squared minus 4x minus 4. So let's attempt to factor this. So 3x and x. All right, negative 6 plus 2 gives us negative 4. 2 times negative 2 is negative 4. So our two remaining solutions are negative 2/3 and positive 2, in addition to negative 1, which we found through our remainder theorem. And because it's a double root, I know that this is going to be a bounce point on my graph. Okay, so I'm always telling you, be aware of the question being asked. So if you were asked to factor, this is what the factored form of this polynomial is. Okay, 4th degree polynomial, I add up my individual degrees, all those things correspond with each other. Now let's do a very simple sketch. Negative 1, negative 2/3 is really close to that, and then positive 2. Gotta have a bounce point here. My end behavior, so it's an even degree with a positive lead coefficient. So I'm going to be up, up. So up, bounce, cross, cross. So now you've done all the work to determine the zeros and then graph it. So this is really putting everything all together. So now after these two examples, you have the ability to go back and practice these problems that I had already assigned. So page 84, numbers 14 to 28 even.